Yeah? All right, everyone, welcome back. We're at Homeport. Next up, as a demonstration, we've got Blue Atlas Robotics. Carl, the co-founder and CTO, is going to give us a presentation on their technology and their platform. And then we're going to have a bit of a Q&A after that. So I'll hand over to Carl now. Take it away.
So, hello, my name is Carl. I am the founder and CTO of Blue Atlas Robotics. And Blue Robotics started as a project to see what it would take to image big things underwater. So we've all seen ROV footage moving around the marine environment, going from thing to thing, but it's difficult to get a large-scale picture of some of these things underwater, especially if you're operating in a low-visibility environment, such as a port or a northern sea environment that's not quite like the Mediterranean. So we built a robot. And this robot is covered with cameras from top to bottom. And the reason we did that is because if you want to see a lot underwater, the first thing you need to do is guarantee that you have a wide field of view. So this robot can see top to bottom 150 degrees. It also has a neutral point of buoyancy and center of mass, which means it's also able to angle under or below a surface, such as the bottom of a ship hull, for example. But that's not enough. In order to efficiently image something, you can't have a human operator precisely controlling an ROV for hours on end. So we've worked a lot on automating this drone through computer vision, such that it's actually able to build a map of its surroundings and environment as it operates. And it can use that 3D map to identify the general structure of what it's looking at and navigate. So this robot is capable of, by itself, with very minimal human assistance, of flying a lawnmower type inspection pattern. So we can very efficiently collect underwater data at a rate of about 1,000 square meters per hour. But once you have that, you have hours and hours of video, and remember, everything's multiplied by 6 now. So you need a way to understand that information. And of course, what we do is we process all that very stable, efficiently collected imagery into a 3D model. So this is an example of a port structure. We can see plenty of information, the different anodes, the welding structure that mounts that anodes. We can also see a lot of information that's only available in the visual spectrum. For example, the color of the soil sediment at the bottom of the quay wall. This can, of course, be an indication that there may be soil leakages from behind the wall, which is, well, it's firstly dangerous, but it's also very difficult to detect, unless you're able to see it in the visual spectrum. We're also very interested in being able to comprehensively inspect a ship hull from close distances. So that's, in our speak, that's about 50 centimeters away. So our system, it does work in the visual spectrum. It does require at least 50 centimeters of visibility, But if we have that, because we're able to efficiently scan these objects, we can stitch them back into these 3D models. This behind me, it shows the structure of a ship hull. We're still working to be able to get that comprehensive image all the way underneath, around the front, the niche areas, the propellers, but we're definitely getting much closer. So that's an introduction to what our technology can do. I'm going to leave a video playing that shows some of us deploying the images, the type of imagery that our robots are capable of collecting, and I'm going to jump into a question and answer session that hopefully we can cover some of the more interesting points. Oops. I'm a geek, so it looks a little different.
Do you want to talk us through the video as it's playing?
Okay, I'll just give a brief introduction to this. So this is typical imagery that our robots are able to collect. And on one side we have the live video streams. On the other side we have some of the information that the robot itself is using to navigate. So as it's moving around, it's building up that 3D map of its environment that's useful for the robot to navigate. It uses that to fit a surface, and therefore the robot's able to take over all the navigation by itself, basically. So that's what this is behind me. It's a lot of the same things, so I think it's maybe an idea to jump into some questions.
Sure. All right, Carl, so thanks for the presentation. I'm wondering where you're showing that video, and you know it's showing the imagery that's coming in direct. What about visibility in the water? I mean, is there a limitation in terms of if the water's really murky or it's deeper? I mean, how much light is required to get good imagery?
So this is Svendborg. It's very close to where we are based in Denmark, in Odense. This is nice imagery. This was done on a day with maybe 2 meters of visibility. It's not quite Mediterranean islands, but it's certainly good enough for our system to work and produce a very good 3D model. Our system is able to operate in 50 centimeters of visibility. And we've done experiments in areas where we'll do a 50 centimeter inspection and get very usable results. But if we move back to 80 centimeters even, the visibility has completely dropped off. We've also taken into consideration the lighting that our robot uses. The lights are mounted in such a way that they illuminate the surfaces from the side. That helps avoid the backscatter. It makes it a little bit better in low visibility conditions. But ultimately, this is a visual inspection tool. We can operate in lower visibilities than a lot of other tools because the autonomy is able to maintain that close and consistent distance. But once you go below that 30 centimeter visibility, it becomes not the right tool for the job, I suppose.
Okay, so to follow on to that question, maybe are you able to talk us through the hardware a little bit? If we put the robot on the floor, and then I think the camera will be able to at least see in general detail. Great. Oops, there we go.
So it is it's an underwater ROV. It has an unusual form factor. This is something that weighs 16 kilograms. It can be easily deployed by a person, and it's designed to be hydrodynamic for moving in a sideways direction, so we can do that underwater scanning. We do have that top-to-bottom camera arrangement. We have the lights on the side. which are protected a little bit by the frame and therefore don't produce as much backscatter in front of the cameras. It has a onboard battery. There's also a topside power solution available. But other than that, even though it looks a little bit weird, it's not so different from any other ROV, a small size ROV that might be used as a tool in a port. The real smarts take over when the smarts on board and the software start assisting the user to efficiently collect that underwater data.
Okay, and I can see a tether here. This is for power or transmitting data, or it's just to keep hold of the robot?
Yeah. So this is a data tether. We're able to stream all the high-definition video streams to the surface in real time. We also have that 3D point cloud, which is displayed to the user and is very helpful for understanding what the greater surroundings of the robot are, especially when the robot itself is pressed right up against the inspection surface. We also have these navigation cameras which point left and right, also to help the user understand their surroundings. But that is a data tether. We have visions that maybe this will be a fully autonomous robot one day, but for now it's a lot easier to pull it out of the water with a tether. Let's leave it at that.
Fair enough. Now, I'm wondering, in terms of the actual use case, I mean, is this a service provider model, sorry? Are you providing a service to the port, or maybe to ships, or will port authorities basically buy this as hardware and use it themselves?
Yep. So we, as a company, our core is technology, and we do see ourselves as a technology provider. At the same time, we realize we're bringing something new into the world, and we do think that we will be performing the additional services to the port customers or the vessel customers. In the future, we'd be likely to work through service providers that are existing around the world, but we've also fielded inquiries of people who just want this robot as a tool to go and check something quickly by themselves without having to order an external service provider to come and collect the data in a traditional way. So there are people that are expressing interest in operating this robot themselves, but currently we're looking at providing the services directly until we're able to put this into other people's hands.
Okay, and can you talk us through a bit about how Blue Atlas Robotics started and maybe how this came into being?
So this once upon a time was a bedroom project. My background is robotics. I've worked in Silicon Valley for 4 years, always at startups. I was into scuba diving, and I wanted to do the most technically challenging thing I could think of, which was to make an autonomous underwater robot. That's the worst way to start a business. Find a value proposition first, but it wasn't too hard to find one. And when we went out and started raising money, it was clear that there was a lot to be improved on ship inspections, both in terms of the quality of the data, the difficulty in getting that data, and the comprehensiveness of those inspections. So instead of looking at point inspections and trying to understand, is this part okay, is this part okay, is this part okay, we wanted to give maritime service professionals, such as technical superintendents of ships, the complete picture of their vessels. So, for example, if they're negotiating a dry dock contract, they can negotiate the services they need more precisely. They can make sure they don't miss anything. We also saw that this was a tool that could be used in a lot more environments than traditional methods. So divers are more and more not allowed to operate in ports around the world. So we do need tools to replace those services that are no longer available. Inspections are usually only taken in waters with very good visibility. That's a problem in the Nordic waters. If this tool can save a ship from needing to sail somewhere with better visibility, and we can do the inspections on site, that saves the ship owner both a lot of money, but there's also fuel savings in that as well as everything else.
Great. I will ask if there's any questions from the audience. So just put your hand up if there are, but we'll carry on a little bit as well. So I'm wondering how deep can this go? And in terms of applications, I mean, I'm a diver myself as well. You know, could you use it for broader surveys that aren't linked necessarily to shipyards or ports?
So this is going to be certified to 100 meters. The environments we tend to work in are never deeper than 20, 25 meters. So going super deep is not a huge concern of ours. But by far the most fun inquiries are the people that come out and say they're trying to monitor some coral reef life and the camera systems they have don't look in enough angles to see all the different life that's going on between the reefs. And there are a lot of potential applications out there. We are a startup, we do have to maintain focus. But I really hope we can do some of those more out there use cases for different people one day.
Great. And maybe just the last few questions from my side at least. In terms of comparing your hardware to other hardware that is out there, what's the added value or the USP?
Yeah. So a lot of people are talking about 3D twins of maritime assets because it is a good idea. The one thing that we've focused on that we haven't seen so much in the competitive space is getting the autonomy to work very reliably. And we've had this robot operating for hours with no interruptions, collecting data very efficiently, and we come back with those hours and hours and hours of data, and we can then post-process them. Because we're able to collect that imagery more comprehensively, to our knowledge, we are imaging the largest structures and doing these photogrammetric reconstructions. But it comes down to just making this a tool that's easy to use, that can be incorporated into whatever operations that it's needed for. It's easy to put in the water, it's easy to take out of the water, and when it's in the water, it can do a lot of the work itself. So you don't have to be a 10,000-hour ROV pilot. And that's our angle, to make this as easy and useful to use to as many people as possible.
Great. And how far along on that journey are you? I mean, how widely has this been deployed? Have you got new deployments in the pipeline? Yeah, talk us through that side of things.
So we are very happy with this form factor of the robot. It's been performing very well. And we are in the early stages of designing the production setup to sell these to certain niche customers. In terms of operating the robot, we've been fielding inquiries for key walls between 1 and 2.5 kilometers. That's a lot more than we've imaged today. So we're really stretching our operational capabilities in being able to not just be efficient while the robot's in the water, but also efficient throughout the working day, throughout multiple days if necessary, and being efficient on the data processing and delivery side. But the robot itself is in its form factor that we're happy with, and if the use case is more about just doing the inspection and seeing the live video streams, we're already able to engage with certain customers.
Fantastic. So I think that's most of the questions I had here. Are there any other questions from the audience right now? I don't think so. I think you were so comprehensive. There's nothing possible to add. Would you like to wrap up with a few final comments?
Yep. Obviously, we're always very interested to talk to anyone who needs to see something underwater and is having difficulty doing it with their tools today for whatever reason. My email address is carl@blueatlasrobotics. Our website is also blueatlasrobotics.com, and if you're able to reach out through that, we will be more than happy to talk to you. So yeah, thank you for today.
Yeah, great. Thanks, Carl. So just a reminder, Blue Atlas Robotics will be here for the rest of the week. You have a stand somewhere, right?
Yes, we're downstairs in the container.
Okay, so if you come to the home port, you'll be able to find them at the stand. And I think you will also be presenting again a couple of times, right?
I believe so. Yep. Don't hold me to the schedule.
Okay, all right. So with that, we'll wrap up this session. Next up, we've got Volocopter, I think starting at 2 o'clock. So we'll draw the session to a close. So thank you very much, everyone, and thank you, Carl.
Yep. Thank you very much.